Hello, you're welcome. You're welcome onto my channel today, and it gives me great joy to observe you are viewing this video. I'm Dr. Olayinka Akanle. I'm a lecturer in the university. I'm a researcher. On this channel, I do a number of stuff, but all the stuff I do on this channel, you can easily cluster them into four. So I do sociology, I do research, migration, and relationship. So the video you are viewing is within my research video. So there's a playlist on research on this channel. Kindly go ahead and view the playlist to catch up. So meanwhile, if you have not subscribed to this channel, kindly go ahead and tap subscribe on your screen right now. Click subscribe on your screen right now to subscribe to the channel for wonderful content. So the video you are viewing today is on simple random sampling, SRS. Simple random sampling. And don't forget, we have a lot of videos on this channel on sampling. To view them, I've dropped a number of videos stratified, stratified, cluster, systematic, random sampling. Also, I've done purposive sampling. So catch up. And I will still drop more after this. So make sure you stay tuned to build capacity in sampling. So, and this simple random sampling, why I'm actually dropping this video is because it's about the most abused sample selection method. Most abused. I've seen so many thesis, dissertation, operation research report, consultants report. Many of them just say we use simple random sampling, and they don't even know what it means. I said it's the most popular. Let's say that way. It's the most popular kind of. So everybody, when they talk about sampling, have done simple random sampling. Okay, explain why you did simple random sampling and how you did it. No idea. So that's why you have to view this video to the end. Number one, you have to know that it's a probability sampling method. That is, it's an attempt to give every element, every body, everything in that population equal chance of being selected, at least in the first instance. So you want to be sure that every element of that study of that population you are interested in is represented in the sample you are going to draw. Normally we're supposed to do like a census. You want to study a problem, you just assess everybody and conduct the research. But the reality is that it's not possible. It's not realistic. It's just an ideal situation. And also, usually, by standard practice, for you to have a representative sample, you have to take like 10% of the total population. But still, for a very large population, this is not possible. It's ideal, it's idealistic in the sense that the resources you need may not be available. You remember there are challenges, including fund and time. So you have to pick your sample like just like a pot of soup. To taste it, you just take a portion. So what determines the portion is not the function of so many resources. So for you to have an idea of the total pot of soup, you want to taste it or you want to understand. It doesn't mean you have to take the whole pot of soup. You can just take a portion of it. So that portion of it is metaphorically sampling, in research. So and systematic, simple random sampling is just, an approach to randomly, scientifically, methodically, select samples from a total population. Meanwhile, there's a video on this channel on study population. So view that video. So it's a scientific, it's a careful, it's a methodical process of selecting samples from total population. You know, that's why we call it simple random sample. You want to randomly select. That is, you want to be methodical in selecting. And we call it simple because usually it's just a procedure you can follow. And it's usually sometimes the first level in probability sampling, you know. So it's not that maybe it's just so casual method, it's just so basic method. No, it's just the way we describe this process. And it's for you to be able to have representative unbiased sample. Don't forget the reason as you want to sample in probability. There's a video on sampling on this channel you have to view. We have two major types: probability and non-probability sampling. Non-probability does not want to achieve representation at all, just want to get it on purpose. So we use it more in qualitative study. But in quantitative study, we use more of a probability sample. That is, everybody must have equal chance of being selected Every element in the total population must be available in the sample. So it tends to be more methodical, generally speaking, if you like. But essentially, we just want to be sure that there's representation of the basic element of the total population in the sample. And it must be unbiased. Everybody must have equal chance. And it must represent all the elements. And you pick sample, like I said, sometimes for constraints. Resource constraint in terms of time. You may not have the time to sample everybody. You may not have the fund to interview everybody, to study everybody. So another other challenges can be access also to if it's hard to reach population you are studying. And you may not be able to take 10%, so you just want to take a fraction that may not be 10%. You can also do census that population to pick a sample. But this sample must be representative so that you can generalize your findings, because that's also another reason we do sampling. So how do you go about simple random sampling? Number one, you must get the sample frame of total population. You must have access to the total population, their pieces of information, their characteristics. Without a sample frame of total population, it may not be possible for you to do simple random, because you need to have the total population. Though we have approaches to determine sample size for known population and unknown population, but the standard practice is that you should have access to the information about the total population. How many people are in the total population? What are their characteristics, your demographic characteristics, geographic characteristics? You need to have that. If you don't have that, you may be asking question, how are you going to be able to select your sample? How are you sure the sample will represent the total population? Because you don't even have enough information about total population in the first instance. That's what it is. So we believe that you need to have information about total population, and you must have access to the total population. You must have access to the total population is very important. If you don't have access to the population, picking the sample may be challenging. So now, what are the steps you have to follow? Number one, you have to identify the total population. You must identify this is the population I want to study and why. Then you must develop the list of all the members and all the characteristics of the members. Then you must determine the sample size. From this total population, what is the sample size you want to pick? You can determine this. Essentially, we have formula we use for this. I will not mention formula, but you can search sampling formula on the internet. We have a number of them. You must use this formula. It's compulsory. You can't just pick a sample size by your own volition. No, it must follow methodical and scientific process. And the scientific process is to use sampling formula for determining sample size. So that will give you, depending on the number of the total population and some other elements, would give you the sample size. You must use the formula. It's very important. You can't just determine it on your own. So once you identify the population, you develop the list of all the members, you determine the sample size, then you assign random numbers to all the elements in the population. Now, all the people in the population must have numbers assigned to them, because this number that will determine how you pick and who you pick, essentially. And you now use, if it's a large population, you need to use what we call number generator. Numbers generator. Especially we call it computer assisted random selector. Computer assisted random selector or computerized random selector. Just in your normal computer, you can key the numbers into the computer and instruct the computer to pick in a random manner. It will generate it for you. It's so easy. But if it's a small population, you can use lottery system. You can use lottery system if it's a small population. You can do it yourself if your sample size is not so much and the population size is not so large. You can just pick, you can just use, lottery system, to pick from the numbers you have assigned. And if it's a large size, you can use computer random selector to get it. So that's the way you do it. That's what we call, and you must detail these stages, these steps I've given, if you want to, in your methodology, to convince us that you actually did what you came to do. So what are the advantages of simple random sampling? It gives representativeness. It allows you to generalize. It's objective because there will be no bias, and it can minimize bias. Disadvantages: it can be cumbersome. You can still be biased. It's expensive, time consuming. The expertise needed may not be readily available. The logistics needed might be much and can be little under coverage. It may not be to cover everybody. So these are the issues in simple random sampling. Kindly click subscribe on the channel. Till I see you in my next video. Bye for now.